Hello and welcome back to the tutorial. In this video we're going to talk about data frames. They're quite similar to matrices that we've already talked about, with one very big advantage, and that is that in data frames each column can have a different data type in it. And that is quite convenient when we work with real-life data, as usually in our models that we estimate we have both usually character and numeric values. And we would like to store all of those together to have the observations in a row, and all the observations of a single individual or a single group would be in one row. And we can have both characters and numerics, and of course also logical vectors and so on. In order to create a data frame, we first create a few vectors that will constitute our data, and those are essentially the same as we have done before in the tutorial about vectors, with the one difference that I made sure that all of them are of the same length. So here we have kind of 10 observations in each of the variables, which would be, each vector would be one variable. In order to create a data frame, we use the data.frame command, and there's a slight difference to creating matrices. If we want to combine vectors instead of just single values, we use cbind, which stands for column bind, which basically says make each of the arguments, so each of the vectors we've created here, one column in our data frame. That is one variable in our data frame. Finally, it is usually a good idea to set the optional variable here, string as factors, to false. That makes sure that R doesn't interpret our character vectors or character variables as factor variables. If, of course, you have a factor variable, then you can leave this be. The default is true. But if it's, as in our case, just some random character values, then we want to set string as factors false. The rest is pretty much the same. We again use this assignment operator, and in this case we're just going to save it to an object called data. So if we run this, we will have a new headline here called data and our data, and we see we have 10 observations of 4 variables. That is, each of the vectors we pass is seen as one variable, and each row is one observation. Again, we can use the data viewer by clicking on the name of our data, and here we see we have our different vectors. In order to print the entire data frame, that's just the same as with vectors and matrices. We just enter the name of our data frame, and then we get back all our values. As you can see, the rows are just numbered and the columns have the name of the vector. Optionally, we could also set names here by entering a name, equal sign, and then passing the vector, and then those would have the name here. In order to just see the first couple of lines in our data frame, we can use the head command. It defaults to printing the first 6 values, but we can set an optional parameter to more than 6 or less than 6 as required. Accessing columns in data frames is quite similar to matrices. We can just type the name of our data frame followed by the square brackets and a comma, and then the number of the column we want to access. Optionally, we can also use the $ operator after the name and then enter the name of the column we would like to access. And that's why names are also quite important, because it's usually easier in big data frames to remember the name if we've set it to something meaningful than to remember which column the certain variable is that we would like to access. Of course, the same as with matrices, we can again, for example, get the first to the third row of the first column or any other in our data frame and get a couple of values like this. You can play around with it. And again, we can use also the dollar operator, and then we only have one vector, so we don't need the comma. And here in this case, we would do the same as before to get the first to the third value of our character column in data. And this, of course, returns the same thing. We can basically do the same as before in terms of checking the data types. The only difference is that we now need to access a certain column of the data frame, which we can do by passing the name of the data frame dollar and then the name of the vector, or again as we have done before. And we see here that even our numeric vector is seen as character at the moment. And here we are going to present a really important possibility, and that is to overwrite certain vectors within one data frame. And we can do that by accessing that one column and then using the assignment operator and calling some function, in this case as numeric, which, as you might be able to guess, converts the variable to numerics and then just call again the same column of the data frame. And this kind of overwrites the existing numvec column in our data, which is seen as characters, with basically the same values but converted to numerics. In the same way, we can also overwrite single values or a range of values in the same way, accessing them and then overwriting them with the assignment operator. So if we run this and check again the type of our vector, it is now seen as double, which means floating point numbers, and that is a numeric. And we're going to do the same with the logical vector, and we're going to set it as logical. The same would also work if we want to convert to characters. We can say as.character. Now we also have our mixed vector as before. That is right now a character. It has ABC and then a couple numbers and then more characters. If we try to convert that to numerics, we will get an error that NA's introduced. That means that all the character values within that vector are now NA's because they cannot be converted to numerics, and the rest will be converted to numerics. Let's check that out. By clicking on it, we can see the ABC formally is now an NA. Then we get our numeric values, and then we have a bunch more NAs where formerly the characters used to be. So this is kind of something to watch out for if you have mixed values within one variable, that if you convert it to numeric, you will get NAs for all your character values, and those values will be lost. An easy way to check all the data types and kind of get the first couple of values is to call str on our data frame. That will just give us a quick overview. We can see, okay, this is a character, oh, this has some values, this is a numeric, this is a logic, this is another numeric with NAs, and also 10 observations for variables. So this is a really quick overview of what our data looks like. In addition, we can use the summary command, which gives us a quick summary of our data. And as you can see, it kind of gives us a different output for different types of data. So for example, for the character vector, it just gives us, class, character, and length 10. And then for the numeric, it gives us some numeric feedback also, which is quite convenient. Max, median, mean. And so we get kind of an overview of the whole range of our numeric data. For the logical, it gives us a summary of how many are false, how many are true, and how many are not available. And this is also, again, a numeric, so it gives us a numeric overview. That is it for the basics of data frames. Thank you very much for watching, and see you soon.